Alright, I'm going to show off a few of the things that this kind of wall bouncing method allows me to do, and then after that's done we can get into the blueprints and everything. So here, I can bounce and get a ton of forward propelling momentum instead of just bouncing directly off the wall, and it takes into account the angle that I push off the wall at. Another thing that this unintentionally allows us to do is we can grip on to the wall without actually grabbing it and climbing on it. And if we set the values low enough, I don't know if it'll work here, but it allows us to wall slide by pressing our hand against the wall. So as you can see, this has a lot of very useful use cases in terms of VR movement. Another great thing about this is it takes into account how hard the user is pressing against the wall. So if I only slightly press the wall like that, it doesn't really do much, but if I fling myself, I go much further. So now let's take a look at some blueprints and examples. Okay, so firstly, what you're going to want to do is you're going to want to install the VRExpansionPlugin template, which is the map I'm using here, and I'll have it linked in the description so that you can go and download it yourself. I'm not going to explain how to install it. There's tons of resources on how to install the VRExpansion plugin and the template. But once you've done that, you can set up a little platform just so you can test things out and whatnot. But for now, let's just go and work on the blueprints. So first things first, we're going to go to the content browser. We're going to go to all. I'm going to search for grasping hand Manny. And this is the blueprint we're going to want to open up. And this is going to be where most of our code lives. Then from here, what we're going to want to do is we're going to go to our skeletal mesh component. That's going to be our hand mesh. And we're going to go to the asset. By clicking this icon, we're going to go to browse to the asset. We're going to open it up. We're going to go up here. And this is going to take us to the physics asset. Now, once we're here, we're going to do Control A, and that's going to select everything in here. Go to our details and search for hit events. And I have it enabled, but you're probably going to have to enable it yourself. Simulation generates hit events, okay? And that's going to give us an event that fires whenever our hand mesh collides with another object. Okay, so now we can go back to our blueprint here. And we're actually going to do this again. We're going to go up to the detail panels of our skeletal mesh component. We're going to do generates, and now we're going to do the same option, simulation generates hit events, and we're going to enable it. Okay, now that we've done that in our skeletal mesh component once again, we're going to scroll down, and we're going to find on component hit. Spawned it way down here for me. I'm going to drag it up to the top. Okay, now we have our on component hit, and what we're going to use is this normal impulse, and it's just basically going to tell us, it's just basically going to have this value that's how deep we're pushing into the wall, and it's going to be in the normal direction. So what we're going to actually want to do is we're going to take our player controller, or our player character in my case, then we want to drag off and get a reference to the character movement, get character movement, and from here we want to get the add force, connect that here. Now this is different than the normal add force, so there's a reason we want to get it from the character movement. It is actually important that we do that. And from the normal impulse, just so we can see what's happening, because this isn't going to be a big enough value to affect our player capsule, we're going to multiply it. Connect it here. We're going to right click the float. And I'm just going to multiply by 100. It's a pretty good value. Compile, save. Okay, so now that we've done that, I want to go in here and I want to go to all, and we're going to do BP underscore VR, and that's going to find our VR character. This is our main player character, and we're going to go to the event graph, and in this area of the graph that's called toggle laser beams for the controllers, I'm going to swap out this activate right beam, and I'm just going to put the jump and stop jumping. uh, just so we can be able to jump in VR. And I'm gonna go to our motion controller map, hit play. You can try it in VR if you want. I'm just gonna hit the regular play. I'm gonna hit L to pop up my lasers, grasping hand, hit L to put it away. And you'll see, if I jump against the wall, it pushes me back. And if I fling myself, it can fling me up if I catch on above here. If we push off the wall, there's only the force going directly off of the wall. But I want to be able to propel myself forward off of the wall using the wall's friction. So we're going to be implementing a method that kind of works like a pseudo friction. So there's a few ways that I've tried to do this. One of the ways is I tried to use the velocity of the hand, and this kind of worked. It wasn't that good. So I'm going to show you a kind of better solution that I found. And if we go to the viewport and click on the root physics, and we go up to the hand, we can see the sphere. And this is going to be attached to the skeletal mesh. And if we go into the BPVR character, go to the viewport, and move the camera out of the way, you see on these hands, there is the grab sphere. There we go, the grab sphere. And basically, if I undo that camera movement, and then I hit play, turn on the physics hands, you'll see there's two spheres here. There's a red sphere and there's a green sphere. It's kind of hard to see. The green sphere is always attached to the actual physics hand blueprint, whereas the red hand is attached to where the motion controller is. So your actual real life controller. So what we can do is we can get the direction between these two spheres, and that will tell us how and what direction we're pushing off the wall. So if we go to our hand blueprint and we just kind of move some of this stuff out the way, because we're not going to be using it for now, we can break off our hit result. And we just need the location on this for now. But then we can also get a reference to our root physics. And we can get the world location. And then we can also right click and type in physics root. And that's going to be the sphere on our VR character. And you can differentiate them by these two little white dots. These two little white dots mean that it's in this blueprint. And we're just going to get this world location. Okay, and now we're going to get direction, get unit direction from this to this. Actually, we're going to swap this so that it goes backwards. That way we'll be able to see it. It'll come out of the wall. Then we're going to multiply this. Right click, promote to float, and we're going to just set this value to 100. Then we're going to drag off of our event, and we're going to draw debug line. Going to set our location, the impact location, to the line start. Then we're also going to drag off our location again. We're going to add, and we're going to set that up like that. Basically what this is going to do is it's going to get the direction, it's going to offset in that direction by 100, and then it's just adding it to the original position. That way we can get that line. We're going to set the line color to a pink, just so we can see it really easily. We're going to set the thickness to 1 so we can also see it really easily. And we're going to compile, and then we're going to hit play. We got to remember to turn on our physics hand. And then if we press up against the wall, it's a bit jittery, but we can see kind of not the direction, but the opposite direction that our hand is going through the wall at. Or rather, we could see the direction it's trying to go to reach the motion controller. And this is going to be really helpful for us calculating the friction direction of this wall. Now to calculate this friction direction, we need to project the direction vector back onto the wall. The term project isn't entirely accurate in this scenario, but for simplicity, it's how we're going to refer to this process. If you look at this graphic, the yellow circle represents our hit location, the green circle represents our physics hand, and the red one represents our motion controller. Our goal is to get the direction and the magnitude from the blue dot to the pink dot, aka the green arrow in this scenario. We're going to get the direction from our origin to our physics hand by subtracting. Then we're going to use the dot product of the normal to bring the point back to the surface of our mesh. We're then going to do the same for our motion controller. Now, you can technically make the origin point at this blue dot, but it doesn't actually matter in the end, since our output won't be a direction vector, but the location where the point is projected. So now that we have the blue dot location and we have the pink dot location, we can just get the direction between them really easily, and we'll use subtractions to intentionally get the unnormalized vectors. This will make it so that the player will be moved further with a harder push and less far with a lighter push. So to achieve what I just demonstrated, we're going to make a function, and I've already made it here, and I just called it project onto face. I'm going to open it up so you can see what's going on. I'm actually going to move this so it's a bit more readable. So you'll see we subtract the point and the origin, we get the dot product to the normal, and we multiply that dot product by the normal. Let me plug it into this and subtract it again. And this is going to allow us to basically project it back onto the surface. So we can actually get rid of this get unit direction. I don't know why it's not letting me delete it. Okay, I'm going to have to close out of this blueprint and open it back up. It's a fun little Unreal Engine bug. Okay, and now delete. So now we're going to take this project onto face function. We're going to drag it out. We're going to put the normal in here. And we're just going to take the root physics for the actual hand blueprint. And we're going to drag that into the point. And we're going to drag this location into the origin. So we're going to want to do this again for our motion controller, or our physics root, as it's called. So we're just going to duplicate this function. And we're going to drag off the normal. This is our target point, and this location is going to be our origin. Then from here, we're going to do a subtract. And then this is what we're going to plug into this value. And now if we go up to this wall and we drag across it, we can see that the line goes in the opposite direction that we're dragging, more or less. So now back in our blueprint, we can bring our add force back in. Remove this connection, and then we can actually have a different multiply. We're going to multiply, and we're going to do it by a bigger value. Do float, and we're going to do 10,000. Actually, that looks more like 100,000, but it'll be fine. Okay, so now if we go up to a wall and we fling directly down, it will fling us directly up. But an issue with this is now we want it to also push us back, because we don't want it just to push us up. So we can go back into this blueprint. Then we just copy and paste this add force. And we're going to move this beyond this. Drag this in here. Make it execute afterwards. I'm going to plug in this normal strength, normal impulse strength into there. We're going to make sure this is connected as well. We're going to save it, compile it. And now We turn our physics back on. We can jump up against the wall and it'll fling us up and back. But if you pay attention, you'll notice that even if we push straight off of this wall, it's going to push us up without us wanting to. And even if we push off against this, it's going to drag us in a direction that we don't even want to go in. We just need to compare the wall normal value to the hand direction. And we can do that really quickly in Blueprint. So now we actually are going to get direction. Get unit direction from and to these two connections. Actually, we want it to be backwards, so we want this to here and from here. And then we're going to take this normal, and we're going to get the dot product, and we're going to plug in this direction vector up into the dot product. Then we want to drag off and get a cosine degrees. Then we're going to drag off of this first add force. This is a normal force. And we're going to add a branch. And then we're going to drag off of this and do greater. And then we're going to set a value. And you may want to play with this value, but I like to have it on 20-ish. Now if we go back into play mode and we turn on our hand physics once again, we see that if we push straight against something, it's just going to push us straight back. But as soon as it starts sliding, it's going to fling us in a direction. And we can actually test this by just walking up to the wall, not jumping, and dragging down. And we'll see that it pushes us up a little bit. So another thing we're going to do just to make this work a little bit better is we're going to get our player controller, our character, once again, here in the begin play. This is the begin play. And we're going to get character movement. We're not going to get all that. We just need this. And we're going to set falling lateral friction. And I'm just going to set it to 0. Actually, we're probably going to move this further in. Like maybe after this is valid. And we just want to set this falling lateral friction to 0 so that we don't lose momentum in the air. Actually, putting it here seemed to produce an error. So while it isn't ideal, what we'll do instead is we'll just plug it up in here after this draw debug line. And now we really won't lose momentum whenever we fall through the air. Now this is going to work way better in VR. Actually, I'm going to put this to 15. I like it actually on 15. That's what I had it set the first time. And I actually also had this set to 100,000. And then I had this value up here set to 200. And it's going to look really extreme in this mode just because you can kind of wildly fling your mouse and you'll just absolutely fly. But if you're using your real hands, you won't get nearly as far. And it's a lot easier to control too if you're using your real hands. Hey, I managed to do it. Sorta. But if you don't want to be able to fling yourself quite as wildly, off of each of these strength multiplier values, you can drag off and you can do a vector clamp size max. So this is going to reduce the max kind of magnitude or length of your vector. And you can just set this to be whatever value you want. Maybe we'll set it to be 500,000. I think that's right. No, it's one too many zeros. That would be 5 million. And we'll maybe do the same here. Plug that into the add force. And basically this won't let our values get too extreme. Although honestly, lowering it to a max of 500,000 might have been a bit much. Or maybe not. It seems like you can still fling yourself pretty crazily. So, that's just another one of those values that you can kind of play with on your own and try to figure out what works best for you. All right, well, that's it for this video. Feel free to copy this code and use it however you want. I'm not claiming any ownership or anything. You don't need to feel the need to credit me or anything like that. It's really simple code. It's not anything to worry about using in your game. And that'll be all. I hope you liked the video. Hope you got some use out of it. And maybe you can use this in your own projects or use it as inspiration for your own methods. And hopefully I can catch you later in another video. Goodbye.